All right, so we're gonna go over everything that we've done so far this unit. So that's why it's called putting it all together. So we're gonna talk about slope, y-intercept, writing the equation, the next now, and making a table. And it's all fairly easy, and we're gonna graph as well. And then we're also gonna talk domain and range again, okay? So if we look at this, it says Nicole had 30 pieces of candy. She eats one piece of candy every hour. So what is her slope or her rate of change? Why is it -1 and not just +1? She eats it, so it takes it away. Perfect. So your slope is -1. What is your y-intercept? Why is it 30? That's where she starts. So our equation is y equals, what was our slope? -1. What goes with your slope? X. And then where do we start? Perfect. Next now statement. Next equals now. What do we write after next equals now? Perfect. -1. Start at 30. Perfect. All right, so if we created a table, we're going to talk about our x's and our y's. So remember, these are always your x's, these are always your y's. To know what to label your table, you can look up here, one piece of candy every hour, one piece of candy every hour. Our y-intercept was 30 pieces of what? So this is your candy. Because your y-intercept dealt with the number of candy. So what is your x going to be? If it says piece of candy every hour or candy per hour, what's your x going to be? Hours. Right. So we're going to start 0, 1, 2, 3, 4, 5. We're always going to start at 0 because we know our y-intercept. What's our y-intercept? 30. So she started with 30. No hours passed. She was handed 30 pieces of candy. What's she going to have after the first hour? Why is she going to have 29? Because there's only one every hour. She eats one every hour, so she takes away. All right. What does she have the next one? 28. The next?
27.
And then 26 and 25. Pretty easy, right? Y'all, that's what we've done this unit. So if you feel like you're not doing really well and you got all those answers, you're doing just fine. Okay, so y'all been doing great. All right, so we're going to graph it. I don't like this graph because this graph goes up to 30. This should be like an L graph. So here's what I'm going to do is I'm going to change your unit. I'm going to make that 5, 10, 15, 20, 25, and 30. Otherwise, we're not getting it on the graph. And then our hours went by ones. So we can do that. That's easy. Remember, X is our hours. And Y was our candy amount. And then you graph your coordinates. Or you graph your equation that you already have. Where did we start? So on the y-axis, we're going to plot 30. And how did we move? Down one, right one. And we just kept going. All right, so you guys see how it touches the x-axis this time, okay? When we talk about our practical domain and range, I'll talk to you guys about that. But I said all the examples that we had were kind of crap examples because usually it's the negative ones that we could really do. All right, so what x values make sense? So look at your x-axis. Remember, if we're talking about candy and hours, we can't have negative. We're not going to have negative candy in our hand. We're not going to have negative hours in the day. So we want all the positive. So what happens is you're only looking at basically what this graph touches. So this little area right here. Okay. So domain are your x's. What's your littlest x value that it touches? So if I make this kind of like this, like a triangle, the littlest x it's going to touch is 0. It doesn't go past that, right? How far does it go before it gets in the negatives? 5. That's your domain. 0 to 5 hours. Because what happens at 5 hours? Not 5, but 6. Sorry, what happens at 6 hours? You only have what? Oh, I did this. I did this. I did this. So right here, when we graph this, I messed up. Okay? Realize I messed up. Because, mark this graph out. This is my fault. Let's make a new one. It's been a long day and a long week. Y'all know it, and y'all have only been here for 2 days. I'm so sorry, y'all. All right, are you ready? I messed up because I didn't follow my scale. I can't go down 1 because this is down what? 5. So I actually have to go down 5 over 5. Does that make sense? Why? Negative 5 over 5 is negative 1. So I went down 5 and over 5. That means my graph is going to look like this. It's not even going to touch the x-axis. So then your domain is really crappy. All right, but we can still do it. Okay. Domain is your hours. What's the least amount of hours you're going to have? Same thing it was before. 0. If I started with 30 candies and I eat 1 an hour, how long can I eat candy before I run out? Okay. If I start with 30 candies and I eat 1 an hour, how long can I eat candy till I run out? That's your max. Why would I eat 31 hours? Because I won't have any candy. Does that make sense? So that's the practical domain and range that I said we would get back to. Okay. What about your range? Your range is your Y's, which is the number of your candies. What's the least amount of candies I can have? 0 candies. What's the max amount I can have? 30, because I started with 30 and I keep decreasing instead of increasing. So this is kind of what you'll get on your test. You'll get one like this and you'll have to tell the practical domain and range. So I think it's a snowman melting. So it can melt till it melts no more. So 0 to how many hours it takes for it to be completely melted. How tall will it be? It'll be as tall as it starts to 0. Okay. So again, on your test, it's going to be a snowman. I'm telling you right now. All right, Estella had $50 for her birthday. She wanted to purchase a new pair of shoes for $120. She can earn $5.50 an hour to babysit. How many hours does she need to babysit? So what's her rate of change? What's her slope? $5.50. What does she start with? She started with $50 for her birthday. So that equation is y equals 550x plus 50. Perfect. All right, somebody else, what's your next now? Next equals now. Perfect. Plus 5.50. Start at 50. Perfect. Create a table. It's $5.50 an hour. Your y-intercept was 50. What is that? 50 what units? Dollars. It's your money. So your money is y. So if it's money per hour, what is your X? Hours. We always start our table with our y-intercept. So we started with 50. If she earns $5.50 an hour, what will she have after the first hour of babysitting? $55.50. Remember, we're going up by 5.5. What about the second hour of babysitting? Try again. Because you have 50 cents on both of them. So 61. That's all right. What about the third hour? 66.50. The next hour? 72. Don't forget your 50 cents. So 66 plus 5 is 71. And then the 2.50 cents bumps it up to 72. And then the last one, which is easy. 77.50. Perfect. Does she have enough for a pair of shoes yet? No, she's gonna have to keep working, right? All right. So we're gonna graph it. I'm not screwing this one up, okay? We're gonna do the same thing, except for I'm gonna do, no, I'm not. I did just screw it up. Don't write that down. Let's see what scale. I use 20. 20, 40, 60, 80, 100, and 120. And the reason I went all the way up to 120 is because that's what she wants. She wants the 120. 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. I'm going to show you a different graph too. It's going to be the same as okay. All right. So then we started at 50, which would be right here. I'm going to plot the chart because it makes it a little easier. 2 was at 61, so that'd be like right there. I didn't plot 1 because I don't want to plot 55.50. I'm just going to plot my whole numbers. 4 was at 72, which is like right there. Now I'm going to show you what would be easier. I think Miss Rose made these notes. We did not. I still like them. I just don't like the graphs. Okay. So I'm going to show you a different graph. So I could also, let's see what I got. 1, 2, 3, 4, 5, 6. Graph it like this. And because I go up by the same amount, I can start at 50 and do 55.50, 61, 66.50, 72, 77.50, and then it's a really easy graph. So if I tell you to sketch it, I would just do that. This should have probably started earlier, but so that's easy. So easy enough, make your little sketch and move on. You didn't have to sketch that. I was just trying to show you if you had to do it by yourself. All right, domain. Domain is the number of hours. We'll talk about that in a minute. Let's look at your range real fast. Range is money. So what's the least amount of money she will have? Be careful on this one. What's the least amount she'll have? 50. She had it already. That's the least amount she'll have. What does she want to get up to? 120. So that's going to be our practical range. The question is, how long will it take her to get there? How long will it take her to get there? What's the least amount she can work? 0. So then I'm going to show you this. At 5 hours, we had 77.50. This would be 6 hours, 7 hours, 8 hours, 9 hours, 10, 11, 12, 13. So how many hours would you have to work to get to 120? 13. She wouldn't want to work any more than that. And again, that's why the increasing ones are a little bit harder because you have to do extra work. So on the test, I probably put a decreasing so you can get it done really, really quick. Okay. We're going to flip it over. And we're going to do the same thing. This question right here is just like your test. You have a question very, very, very similar to this on the test. You'll have a question very similar to this on your review as well. Okay, so we'll go over it again during your review. All right, Brasidia and Jennifer built an 8-foot snowman. The sun came out the next day and the poor snowman melted away at a rate of 1/2 foot per day. How many days until the snowman was gone? So what's your slope? What'd he do? He melted. So what's our slope? Negative 1/2. Guys, y'all need to be on time. Our slope is negative 1/2 because he was melting, so he's getting smaller. What's your y-intercept? Where did we start? At 8 feet. So what's our equation? Y equals? Perfect. Next now statement, next equals now. Minus 1/2, start at 8. Perfect. Watch those signs. You did great. What is your X and what is your Y? Here it is. 1/2 foot per day. We started at 8 feet. So that's your Y. So your height is your Y, or you can just put feet. So what's your X? Days, yep. You can put number of days, day, I don't care. That's not important. We start with our y-intercept. How tall was the snowman before he started melting? 8. And then we keep going up by days. 2, 3, 4, 5. He melted 1/2 foot per day, 1/2 foot per day. So if he was 8 to begin with, how tall would he be the next day? 7.5. The next day? 7. And then 6.5, 6, and 5.5. On our graph, I'm going to make it scale by 2, 2, 4, 6, 8, 10. On the bottom, you can do the same thing. Just trying to get you used to seeing different scales. So watch how they work, okay? The reason I did it by 2s is because every 2 on the x-axis is your whole number. So I didn't want you to have to plot half points, but you can, it's fine. All right, so 0, 8 was your first one. Then we had 2, 7, 4, 6. So if 2 is 7 and 4 is 6, what will 6 be? Keep going in your chart. 6, 7, 8. So look at this. Every other one I'm going down by 7 to 6, 6 to 5, 5 to 4, skip 9. 10 is going to be at, 3, sorry. 11, 12 will be at, and 14 will be at 0. So how long did it take him to melt? 14 days. So we'll need that in just a minute. There's your graph. Sorry, that's a 3. That was terrible. I apologize. Oh, it's not 14. What is this one going to be? 14 will be 1, 16 will be 0. Sorry, y'all. It's a bad day. That's only going to help us on our domain and our range. So our domain is our X. How many days did it take him to melt? 16. It's easier, again, on the test because it goes by a little bit more. So 0 to 16 days to melt. How tall was he to begin with and how short can he be? So littlest to biggest, what's the least size that he can be? What's the least height he can be? 0. What's the max height he can be? There we go. There's where the 8 comes in. He can only be 8 foot tall. He can't be any taller. Look at it one more time. He can only be 8 foot tall. That's as tall as he gets because then what's happening? He's melting, so he drops down. The least he can get is a 0 height. We can't have a negative height. All right. Now it's just some crazy stuff you got to fill in. It's not hard. We're not going to graph. I'm not going to make you graph, okay? So we're going to do everything else. It will take no time at all. We're almost done. There are 2 inches on the ground at midnight. Each hour, the snowfall increases by 1/2 inch. So what's your slope?
1/2.
1/2, and it's a positive because it's increasing. Good. What's your y-intercept? How much snow did we start with? 2. So what's our equation? Perfect. What's our next now statement? Next equals now. Perfect. Your table and your sequence are exactly the same. Your table and your sequence are exactly the same. So your table, we started at 2. So 0 means you start. 2 is where you start. We're increasing by 1/2 inch. So at 1, how many inches would we have? 2.5. At 2, 3 inches. And at 3, we would have 3.5. Your chart is exactly the same. The initial value is 2. At the first hour, we have 2.5. At the next one, we would have 3, 3.5, and 4. I'm not going to make you keep doing that, and I'm not going to do practical domain and range. Okay? So no graphing, no sequence, no practical domain and range. All right, so now they don't give you the situation. I'm not going to make you write a situation. You're not going to have to do that, so we're not going to worry about that. Okay, but we have this equation. What's your slope? 1/4. Yes, ma'am. What's your y-intercept? 6. What's your next now? Perfect. Your table, what's the first coordinate that I start with? The first row. 0 what? What goes in the y? 6, what we start with.
6.
Perfect, yes. Our slope is 1/4. That means we go up by 1/4. So at first hour, what is 1/4 as a decimal? 0.25.
20.
Yes, yes, 6.25. Your second one go up by 25 again would be 6.5. And the third hour would be 6.75. Again, this sequence is exactly the same. I don't care about the graph or the practical domain. Okay. Everybody good? This time they give us the table. So remember, 2 things come from the table, your slope and your y-intercept. Where is your y-intercept on the table? 3. It's always the number with 0. So your y-intercept is 3. And then tell me what's happening each time. Plus 2.5. So what is that? The slope. Perfect. And it's a positive 2.5 because it's going up. What's your equation? Perfect. And last is your next equals now. Next equals now. Plus 2.5. Start at 3. Excellent. So at the top, when it's asking for a situation, it wants you to make a word problem. So you take a cab in the city, when you get in, the meter starts at 3. It costs $2.50 per mile. Something like that is what she wanted you to write up there, but we don't have to do that. We're good. All right, money in a bank. So they give you this sequence. Be careful on this because they do not give you the initial value or the y-intercept. What's happening every time? What is that number?
Going up by 20.
Yeah, what's that number? It is your slope. So how do I get to my initial value? Minus 20, and it would be? So your y-intercept is 30. What's your equation? Perfect. Your table, always start with 0, and what was our y-intercept? 30, and then we did 1, 2, and 3. Each time we went up by 20, so the next one would be, it's right here. It's the same as your sequence. 50, 70, 90. You don't have to do any hard work on that. Last part, next equals now. Plus 20, great job. Start at 30. Again, all these increasing are hard to do, practical domain and range. Okay, so we're just going to go with what we got. This one gave you the sequence again. Let's do something that gives you something different. All right, this one gives you your graph. This is a good one. So I went down to the bottom one. Okay, I skipped the next one, went down to the bottom. All right, so look at this graph. Where do we start?
2.
2, that's the y-intercept right here. Remember to find our slope. We do our rise over run. Our rise is 2. Our run is 4. Is this a positive or a negative graph? Look at it.
Okay.
So rise over run, and it's a negative. Sorry, y'all. Rise over run is a negative, gives us negative 1/2. If you gave me negative 0.5, it's the same exact thing. So that's your slope. What's your equation? Perfect. Next equals now. Minus 1/2. Start at 2. Great job. This one you can do the practical domain and range because it's one of those negatives and it's a really easy one. So look at your x values. Where does the x stretch from? What's your littlest x to your biggest x? 0 to 4. Perfect. Yep, it's fine. It's fine. Same thing on the y-axis. What's the lowest point that green line touches? What's the highest it touches? That's it. That's practical domain and range. If you make that little triangle, it kind of helps you see that as well. Okay. Getting close. All right. Look at this one. We'll go real quick. This one gives you the next now. Next equals now plus 1/2 start at 3. So what is your equation? 1/2 x plus 3. What's your slope? And your y-intercept. I'm not going to do any more with that. That's an increasing, so your practical domain range will be weird. Well, look at the next one where it actually gives you the table. This is the last one that we're going to do, so bear with me for one more. And we'll get it. Remember, if it gives you your table, to find your slope, you have to do your change in y over your change in x. Here's your y's. 48 to 96. Remember, if you can't remember or you can't figure that out on your own, you can subtract them. So what do I get? 48. So this is increasing by 48. On the other side, how do I get from 2 to 4? And then I just simplify it. A positive 48 divided by a positive 2. Say it again. 24. Close enough. Close enough. All right, so we know our slope is 24. All right, if every 2 increases by 48, every 1 increases by what? 24, okay? So each time, if I make this chart again, so we're looking at 2 was 48 and 4 was 96. To fill these in, this is a plus 48. So that means this is going to be half of it. It'll be plus 24. Does that make sense? You guys see that? So if I go backwards, this will be minus 24, which will give us 24. But that's not our initial value or our y-intercept. We got to go back again, 24. And what do we get?
0.
So our y-intercept is 0. What is our equation? Do I have to put the plus 0? Can you? Absolutely, you can. Okay, so don't feel bad. If you need it there, use it. Next equals now. Plus 24, start at. Perfect, 0. Yep. Any questions? All right. If you are good to go on